Right now, wherever you are, I want you to literally look up. Whether you're staring at a ceiling, some drifting clouds, or a bright blue sky, you are looking through something absolutely incredible. What often just feels like empty space, it's actually this vast, heavy, invisible blanket of air, held firmly in place right above us by Earth's gravity. It is, without a doubt, our planet's most critical life support system. Okay, let's dive into this explainer and see exactly what's hovering right above our heads. Consider this our flight itinerary for today. We're charting a literal ascent from the ground all the way up to the edge of space. We'll start with Earth's invisible life shield, check out the exact recipe of air, and climb up through weather and the ozone. Then we're pushing into the extreme realms of meteors, auroras, and space before dropping all the way back down to look at weather versus climate dynamics. Buckle up. Section 1. Earth's invisible life shield, which is way more than just empty space. We are starting our journey right down here on the ground, exploring a life support system held tight by gravity. Standing on the ground, we're basically at the very bottom of a massive ocean of air. It's super easy to take for granted, right? Because we can't even see it. But this invisible ocean is doing some seriously heavy lifting to keep us alive. And this brilliantly illustrates how it performs three absolutely vital functions. First up, survival. It gives us the precise mixture of essential gases that every living being needs. Second is protection. It acts as a literal planetary shield, filtering out the sun's harmful ultraviolet radiation. And third, regulation. Our atmosphere traps solar energy to maintain a stable, livable temperature. It's kind of like a giant greenhouse, actively preventing Earth's heat from just escaping out into the freezing, lifeless vacuum of space. Without these three functions, there's just no way life as we know it would exist. Moving to Section 2, the recipe of air, the gases that actually make life possible. Let's analyze exactly what we're breathing in right now. To really get how this life shield works, we need to know what's filling our lungs with every single breath while our feet are planted firmly on the ground. Looking at the breakdown here, there's a sheer dominance of just two elements. A massive 78% of our atmosphere is nitrogen, followed closely by oxygen at 21%, which, is the one we absolutely need to survive. Together, that accounts for 99% of the air around you. But pay super close attention to that tiny 1% slice left over. It seems like a mathematical rounding error, right? But that tiny fraction holds some of the most dynamic and powerful elements on our entire planet. So let's unpack that last 1%. Argon actually takes up the bulk of it at 0.93%. Carbon dioxide, despite all the massive global impact we hear about, is present at just 0.04%. Then we've got trace amounts of things like helium, neon, krypton, xenon, hydrogen, and just tiny dust particles floating around. Now, what's really interesting about this breakdown is water vapor. It makes up anywhere from just 0.1 to 0.4% of the air. But that incredibly tiny fraction, it's the absolute powerhouse driving all cloud formation and precipitation on Earth. Small, but unbelievably mighty. And keep in mind, this specific recipe changes as we go up. Section 3. Weather and the ozone. We are officially beginning our ascent into the layers. Blasting off from the surface where air density is highest, things are about to thin out fast. Our very first stop is the troposphere. This stretches from the ground up to roughly 12 kilometers, and it is the densest, most chaotic layer of our entire atmosphere. It holds almost all of Earth's water vapor, making it the undisputed weather layer. Think about it. Every single thunderstorm, every foggy morning, every torrential rainfall you have ever seen in your entire life happened right here in this 12-kilometer stretch. And as we climb higher up through it, the temperature drops rapidly. It gets colder and colder the higher we go, until we hit a very specific ceiling. That ceiling is what atmospheric scientists call a pause. Simply put, a pause is the specific boundary layer where one atmospheric region ends and the next one begins. So right now, we are crossing a threshold called the tropopause. Crossing this invisible boundary means we're leaving that dense, stormy weather behind us and entering a totally new, surprisingly calm environment. Welcome to the stratosphere. We are now cruising between 12 and 15 kilometers above the Earth. And once we cross that tropopause, a totally wild thing happens. The temperature trend reverses. Yep, instead of getting colder, it actually starts warming up. Plus, because it's completely free from weather disturbances and clouds, the air up here is incredibly smooth. That's exactly why your commercial airline pilots prefer it as their cruising altitude. But the real headline here, the stratosphere houses the ozone layer. This is that vital planetary shield we talked about, actively filtering out the sun's harmful ultraviolet rays so we can safely thrive down below. Section 4. Meteors, auroras, and space. We are venturing into the deep, cold, and high heat. We're leaving the comfort of the lower atmosphere now, heading into something vast, extreme, and awe-inspiring. As we cross the stratopause and hit the 80-kilometer mark, we enter our third layer, the mesosphere. Here, the temperature violently plunges. It is absolutely freezing. But do not underestimate this layer for a second. It serves as our crucial first physical line of defense against space debris. When rock and ice hurtle toward Earth, it's right here in the mesosphere that friction causes most meteorites to literally burn up upon entry. Basically, it saves us from needing to wear hard hats on our morning commutes. Pushing past the mesopause, we enter the massive thermosphere, stretching from 80 all the way to 700 kilometers out. Now, the temperature doesn't just rise here, it skyrockets. This layer is an active, invisible battlefield. The sparse gas molecules up here are constantly bombarding and absorbing deadly X-rays and shortwave UV radiation coming straight from the sun. And this intense energy absorption does two amazing things. First, it creates the ionosphere, which literally bounces radio waves back to Earth, making long-distance communication possible. And second, that violent collision of solar energy and gas molecules creates those breathtaking glowing scars across the sky we call the northern and southern lights, or auroras. Finally, we reach the exosphere, the very edge. Up here, the air is unimaginably thin. Earth's gravity, which has held everything together so tightly up to this point, is now incredibly weak. In this silent, final frontier, our protective atmospheric veil just sort of bleeds out. The lightest gases, like helium and hydrogen, are no longer bound to our planet. They simply slip away, floating out into the endless, freezing vacuum of space. Section 5, Weather versus Climate Dynamics. Let's move to and see how this builds, exploring how these atmospheric layers impact our daily lives. We've traveled 700 kilometers up, but now we need to plummet our focus all the way back down to Earth. Because as fascinating as the edge of space is, the interactions within all these massive, invisible layers we just flew through, they dictate our everyday reality on the ground. As these layers shift, we experience the results as either weather or climate. And it's absolutely crucial to understand the difference between the two. Weather is the short-term, chaotic stuff, the hour-to-hour, day-to-day conditions. It's what makes you decide whether to pack an umbrella or throw on some sunglasses. Climate, on the other hand, is the massive, long-term mathematical average of those daily conditions over a huge area strictly measured over a period of 30 years or more. Simply put, weather is a snapshot, but climate is the whole movie. Now, both that daily weather snapshot and that 30-year climate movie are driven by the exact same core elements. We're talking temperature, precipitation, humidity, wind, and atmospheric pressure. So the crucial point is understanding what powers all of these drivers. The master engine behind the whole shebang? Insolation. Insolation is the total amount of solar energy actively received by the Earth. That incoming solar radiation dictates the temperature distribution across all those layers we just traveled through. It drives the winds, it evaporates the water vapor, and it orchestrates this entire dynamic system that keeps our planet alive. From the dense, stormy troposphere that waters our crops, to the ozone that shields our skin, right up to the thermosphere catching solar radiation and painting the sky with auroras, we are so incredibly lucky. It is not just empty space above us, it is a complex, perfectly balanced ecosystem. But as vast as it seems, this protective veil is fragile. The balance of those gases, especially that critical 1%, is highly sensitive to change. Which leaves us with a necessary question as we wrap up today's explainer. We are protected every second of every day by this fragile veil, but are we doing enough to protect it?